Greetings and welcome to my new calculus channel. My name is John Gabriel. So, I've been getting from so many stupid people the same comment on the mean value theorem, and I want to clear it up once and for all. So, this guy says, I think you've got the direction of the implication the wrong way around. You see, and by the way, this is a result of being brainwashed incorrectly to think that the mean value theorem has something to do with logic and set theory. It has nothing to do with logic and set theory. And so the MVT states that you can find some point within the interval to satisfy that condition. Okay. So it says there is a C such in the interval such that the difference quotient given is equal to it. It does not state that any given point C will have a corresponding interval AB. It doesn't have to state that. And that's not what I'm saying is the problem with it. So this is how I answer this guy. I say, you do not think properly. Nowhere do I claim that is what the MVT says. Not once have I ever claimed that. If you paid careful attention, I demonstrate that the actual problem of the statement is problematic. Why is it problematic? Because the MVT claims that a function is differentiable at every point in the interval. Okay? If it is not differentiable at even one point in the interval, then it doesn't apply. Right. So a result, pay careful attention now, concentrate. A result of this claim is that there is at least one point where this identity is true. But this does not negate the fact that f must also be differentiable at an inflection point. Okay? That has nothing to do with the mean value theorem. The mean value theorem says that if there is an interval, every point must be, f must be differentiable at every point. Okay? Because if we adjust the interval to some appropriate AB, then there must be a difference quotient, as you see here, fb minus f over b minus a, such that f prime of c, c being the inflection point, is equal to this difference quotient. Okay? This never happens. And the actual interval itself is irrelevant because it is not unique, as I've shown you. Okay? If there is even one interval AB that works, there are innumerably many others. And I went to a lot of trouble to show you morons. Look here. Here's one AB interval, okay? One AB interval. And I could, of course, just write down these 2 points. So I could say here, just show the damn label. Okay, and I want to see the value. The value and the value. Okay. So here's the interval. It's minus 2.04 to minus 0.55, okay? There are many different intervals. Any of these intervals will do, okay? So I think in here what I've done is I've actually stated XA. I've stated A and B, so we could just basically pull this out here and pull this out here. Okay, come on. What happened there? Did I get that out? Let me just do that again. Sometimes I think this happens just to annoy me. Of course it doesn't, but somehow I can't get it out now. Okay, there you go. I think I got it. Let's just close this here. Must be somewhere here. Here it is. Okay, so here is the interval, okay, people? So it's from A to B. There's C, this green spot, this green dot here, okay? So look, do you see there are innumerably many intervals, okay? Innumerably many. Right, but if this point C is an inflection point, like over here, there is no such interval, okay? No such interval whatsoever, all right? There should be, because the mean value theorem says that f must be differentiable at every point in the interval. So coming back to this idiot's comment, if there is even one interval AB that works, there are innumerably many others. It's irrelevant. The size of the interval is irrelevant because it's not unique. And the fact that mainstream academics have never understood this is yet another proof of what I have been claiming all along, that they have no clue why calculus works, and that the mean value theorem is the reason calculus works, because the mean value theorem is the fundamental theorem of calculus. And in my closing video epilogue, it was called MVT 8, or the epilogue, I showed that you can find the C for under any function, okay? The level magnitude, or the arithmetic mean. The level magnitude is the arithmetic mean. It doesn't matter what function you have, there will always be a level magnitude, and the interval has nothing to do with it, okay? Because every interval will have a level magnitude as long as it is smooth, meaning differentiable at every point, okay? That's all I have to say. If you're not already a subscriber, become one. Click on my channel, tell your friends about that, follow me on academia, and join to get much, much more than what I normally share with the public. It's only €5 a month. I'm John Gabriel. Till next time, goodbye.